Hello and thank you for joining me. This is going to be a short calculus exploration of, reinforcement of an old concept. And we're going to dip our toes into something new just by taking a slight variation on what we've done in the past. So I've got a problem on the screen, and your task is to evaluate and explain what your answer represents. You're given two functions. F of x is a quadratic and g of x is a linear function. And so I would like you to pause the video and take a minute and do these three questions, parts A, B, and C. Evaluate those integrals, explain what they mean. Yeah, that means you actually need to get paper and pencil. You can't do these in your head, folks. Sorry about that. So grab some paper and pencil, and these are not too bad. I would go ahead and do these. Without your calculator, like I said, we're going to simultaneously reinforce what we already know how to do and then build on it. Okay, perfect. So now that you've had a chance to try those questions, let's do a quick answer check. So for the first one, we should have gotten 18 for that. And for the second one, we should have gotten 6 for that. So I'm going to take a minute and show this on the screen. Please pause and take a look at my work. This over here is part A. I'll briefly talk through it. So we had this integral. I did the antiderivative of each term separately. I forgot to put the dx there. That's just a notation error on my part. So we're going to do each term separately. So I get negative x cubed over 3, negative 2x squared over 2, and 6x for the last term. And then don't forget I'm plugging in the upper and the lower limit of integration, subtracting the 2. Let's make a habit right now of putting parentheses around that. I love it when we have 0. Everything went away. Doesn't always happen. I just didn't have any constants here. So I ended up with 0 for my first entire part and then plugging in my negative 3. Lots of parentheses because I've got a negative. And chances are if you made a mistake, it might have been just a negative sign. So let's do a quick check for B and then we will figure out what it is that we did. So B should be over here. Obviously pause if you need to spend a little more time with it. And very similar process there. Okay, so what did we do? Well, an integral since the beginning of time, since the beginning of our time working with integrals, an integral has represented none other than, you got it, area under the curve. So we found the area under two different curves. I say the term curve loosely because obviously one of these is a linear function, but we found two different areas. So I'm going to take a second and do a quick sketch here and use some algebra knowledge to help me out. For my quadratic, I just want to get an idea what this looks like. So I'm going to do a quick reminder to myself that I can do negative b over 2a gives me negative 2 over 2 times negative 1 gives me negative 2 over negative 2. That means I get positive 1 for the x value. Nope, that's a 2 times a is negative 1. Positive 2 in the numerator, my bad. Okay, so that gives me a negative 1. That was supposed to be the easy part. Negative 1 for the x value of my vertex, of my parabola. When I plug that in, see if I can do better here. Negative 1 squared is going to be positive 1 minus 2 times a negative 1 is plus 2. Plus 6, that's giving me 8 minus 1, which is 7. So I'm getting a vertex point of negative 1, 7. This is just so I can get a picture of it, folks. Okay, so if you are really stressing out by this, you can grab your calculator, but figured this was not too bad. So it looks like that's the x value, or sorry, that's the vertex of my parabola. And I'm just going to go ahead and do a quick sketch here, not a great sketch. Okay, so that's my attempt at sketching my parabola, and the first thing that we did is we calculated this 18 area under the curve that's under my parabola. That would be from negative 3 to 0, and I would represent that by this region right here. Okay, so that should be our first answer. And then if we take the time to sketch the linear function in here, plus 3, y-intercept of 3 down 2 over 3 puts me right here. And I have something like that for my g of x. And if we're going with integral as area under the curve, then this represents the area under that line, which would be that region right there. So I just want you to take a second and stare at that. And then I want to entertain part C. And I don't know about you, but I'm not going to do a bunch of extra work for part C, so I hope you didn't. I don't need to recalculate that integral because I have this property of integrals that tells me that what I'm asking you for is equivalent to this. And I think we've gotten pretty comfortable with working with that flexibly, splitting them up, at least if we do it in our head. That's 18. This is 6. I already calculated both of those, so therefore this answer has to be 12 when I subtract the 2. Now the real question is, what did I calculate? And if you're looking at my visual, yes, I took time to graph it because I wanted to visualize that. I'm subtracting the 18 and the 6, or I'm subtracting 2 areas. I found the difference between those. Where is that on my graph? It's this region right here. It's the area under the parabola, but above the line. Or could we phrase it as, it's the area between the 2 curves, my blue parabola and my green line. That's what we just did. Do you see it? Slight twist on the concept of, if you're wondering, what is the topic here? Oops. Topic is none other than area which is really just the conceptual understanding of what is an integral. But now we're doing, maybe we're not always going to do area to the x-axis. Until this point, an integral has always represented area between some curve and the x-axis. We say area under the curve, but we really just mean area from the curve all the way down to the x-axis. Or if my curve is below my x-axis, then I do curve to the x-axis, and that we represent it as a negative area. Okay? So now we're going to talk about area between 2 curves. And I want you to entertain the idea of maybe we've always been doing area between 2 curves, but my second curve has always been the x-axis. Couldn't we say that this region here is the area between that parabola and the y-axis? And this one is really the area between the y-axis and the parabola? Interesting thought, right? Okay, so to find the area between 2 curves, what we just figured out is part C told us that we can go take an integral and do between 2 curves by doing f of x minus g of x, where f of x is one of my functions, g of x is my other function, or maybe I could phrase it as top curve minus bottom curve, because I did specifically label my f and g that way. Okay, so don't just go with f and g. So I want you to just visualize for a second without doing a ton of extra problems here. Just visualize what's happening here, because it's pretty easy to observe, I think, and the first picture very much matches what we just looked at. I think it's pretty easy to observe if we have a region that's entirely above my x-axis. So again, this blue would be the integral of f of x if I'm splitting that up and thinking of it as 2. The g would be this, and when I subtract the 2, my answer is that part between the 2 curves. But what happens if one of my curves is below the x-axis? Well, the region that I'm going for is that entire region between those 2 curves. Integral of f of x would be just this piece right here. Integral of g of x would be this. Because it's below the x-axis, it'd be a negative. So if I take the blue area, let's just put a number with that. Let's say that's 10. And I take the green area, let's put a number with that and say that that is 4. And if I calculate that, I'm really doing 10 minus, since this is going to be a negative area, a negative 4. And that's going to give me a bigger area, and we want that entire region. The red would be 14 in this case, numbers just to help us kind of think through that I'd be combining those. And then the last scenario that I think is worth looking at is what happens if both both of my curves are below the x-axis. So now if I'm doing the integral of my top curve, that would be me finding actually this area. Interesting, that's not part of the area I'm looking for. G of x would be this entire area. So I took my blue, subtract my green, which is a larger area. Both of those are negative. So I have a negative area minus another negative is going to be plus. That's bigger. So overall, I'm going to end up with the difference between the two, and my area is going to be positive. So these answers should always be positive because I am finding area between two curves. We no longer have that issue of below the x-axis is negative. What was happening there is I've had, in the past, if I had integral from, integral of, let's just say, f of x for this problem here, what I was really doing is my first curve, like I said, we could think of it as being 0. So if my first curve was really 0, then I always had 0 minus. And therefore, whatever the integral is for f of x, that's the part that I originally had in blue here. All of that we would have said is a negative area. That negative is coming from this right here. That's making it my area below the x-axis as negative. Okay, hopefully that makes some sense. Take some time and ponder that if you need to and make sense of it. Wouldn't it be a bad idea to put this lovely idea in our notes, or at least this? I think it's also something that's going to stick with you because, like I said, not entirely new. I'm going to put one more screen up, and I'm going to give you 4 problems to try. Okay, so same idea. Please try these without your calculator. Like I said, we're going to do 2 things. We're going to reinforce what we know about finding integrals, getting answers. These are definite integrals, and taking a look at the concepts. Drawing a quick picture to picture what's going on, and also to make sure you have the top curve on the top and the bottom as your f of x and the bottom curve as your second function, your g of x. So they might be something that you just want to draw a quick sketch so you can see what's going on there. So I'm going to leave this up so you can write those problems down, and you're going to try those 4. I'm going to make 4 separate videos, or at least a couple, maybe I'll do a couple together, to go through the answers. I just don't want to have a super long video and then something to go wrong. So I will put those in, and you can check your work, follow along if you are confused, and see some more examples of this. Thanks for joining me.